To just give a background that this is the eighth session for this ongoing cycle of DevOps internship. Okay, so the previous seven sessions we had discussed about AWS, a bit of Linux, a bit of Git, and the GitHub and the Git. Then we had Terraform, we had Ansible, and then we had a combination of your CI/CD pipeline, that is GitLab, with Ansible and Terraform. So there were very live sessions, very interesting sessions where we had hands-on on certain demos where we involved GitLab automation pipeline along with either Ansible or Terraform, so that we knew both. I mean, all the three subjects like Ansible, Terraform, along with GitLab. Okay. Then we also did two sessions on Docker. Docker first part, we had a good understanding of the theory. And the second session we had on Docker hands-on. That was also very interesting. In all, we had 7 sessions right now. Today, we are going to start with Kubernetes. Kubernetes, we are going to devote today and another, the next weekend, the Saturday, the same time. 2 sessions, I think. It is never enough. Kubernetes is such a big and vast ocean-like subject. And I also find it difficult to complete Kubernetes with a good understanding, but it's okay. I still could manage with 6 sessions in my main course. I somehow being able to finish it. So, but the understanding is that within 1.5 months, within 6 to 7 weeks, I had to complete the entire suite of DevOps tools. And as Karthik was saying, there were DevSecOps. The learning curve is, yes, stiff, because if you are directly jumping into DevSecOps, then it will be a bit tougher to learn. But if you are coming from a DevOps background and then going over to DevSecOps, it becomes a cakewalk. But because DevOps has many tools and a combination of so many tools, and each tool should talk to each other in such a way. So that learning DevOps, it takes a lot of your grooming and lot of hard work. So anyhow, the question was like the Kubernetes. We are going to start Kubernetes today, and we will take 2 sessions from today. Let us understand how Kubernetes, what is the architecture, why we use Kubernetes, and all. So the recording is on, I think, yes. I will start sharing my screen. You will let me know if the screen is visible. If you
Yes,
can
we
tell
can
me,
see. Yes, we can see.
can you see the screen?
Yes.
Great. Kubernetes generally in our main course will be the last topic, because I cannot put Kubernetes in somewhere in between. This is one of a bit of, it takes a lot of understanding the theory, because it is not very simple. It has a complicated architecture, and to understand the functionality, it takes a bit of grooming and good bit of understanding. So we will unlock the future. So here what we see is DevOps. This is the very famous DevOps. Intertwined. Each phase is talking to each other. Now, in my question was, where should I place Kubernetes? In which phase of a DevOps lifecycle? It is in the operate, where you also have Terraform, also have Ansible. So we have already learned about Terraform, Ansible. We have learned about here it is Jenkins, but we have learned about GitLab. Okay. We have learned about Git, Linux, Docker, uh, And of course, all over AWS, the cloud. So let us begin with Kubernetes. This Kubernetes comes in the operate part. Operate means where you have already deployed your application, you have already automated your pipeline, and then the automated pipeline has gone into production or maybe pre-production where you will operate. I mean, this is mostly done from the operations point of view, but as a DevOps engineer, you cannot escape any phase. This, you are the owner of all these phases. Okay. So right now, I am in the operate phase after we have successfully deployed the automation pipeline. We are going to monitor, we are going to orchestrate our microservices. The microservices are where you have deployed your, you have modularized your entire monolithic. It is no longer monolithic application. You have divided your application into smaller chunks of self-sustained application. So it's an application in its own. They are called microservices. And those microservices are contained in a container. And the container, now there will be hundreds and hundreds of containers. So there is a
Sorry,
lot of,
Mr. Debashish.
yeah.
Can I please ask?
Yeah, sure. Why not?
So microservices, could they also be a feature? I just want to understand.
Uh, if you
Because you
take
say,
if you take, yeah, tell me.
Because you said it's more like a self-existing sort of,
Yes.
yeah,
Yes.
I don't want to say entity, but like mini application. So a feature
Yes.
can be that.
It is a part of the, see, let's say you are talking about an e-commerce application. Do you think that it can exist as a monolithic, I mean, a single layer application? It cannot. It is so vast. It is so
It's too
enterprise
big.
level. So it will be very difficult to maintain it as a single piece of big software.
So
Okay.
what you're saying is there's different components of the application.
Yes. Let's say I have segregated out. Basically, you are segregating it. You are partitioning the main big application into several smaller applications, which are self-sustained, which is, that means it does not have any, these are loosely coupled. That means they are not tightly coupled with the other, parts of the software. That means what I mean to say is microservices are part of the big application, but they are in such, let's say, uh, one part of your e-commerce platform or the software is your login feature, isn't it? You have to log in. Let's say you are logging into e-commerce site of Amazon or maybe Flipkart or maybe Mintra or maybe Walmart, any. So that e-commerce or eBay. So one part could be your login. Login is a microservice. So what I'm seeing that login as one login authentication service, as well as that authentication service is backed up by another microservice contained in another separate container called the login database. So if I am authenticated, that means I have the data, my authentication data like my password or some other authentication methods, that maybe my fingerprint, maybe my uh, so some other identification that will identify myself. I will identify myself as an authenticated user. So that these two, you can say these two are microservice. One is the login application and the other one is the login database. Both work together. So both are contained in separate containers. Okay. In each of these containers, one of these applications, or you can say microservice like login, as well as the microservice for database, login database, both should talk to each other. The main feature of Kubernetes is you have to enable them. Yeah, they are Docker containers, but Docker containers is not sufficient. You have to enable in such a way those microservices should talk to each other. If my login data cannot be authenticated with my login database, then there is no point.
Mm.
But they are loosely coupled. You see, they can exist separately. If something has gone wrong with my login application, I do not need to touch the microservice which is running as a database. I mean, the login database. I will just correct that functionality. Some, if there is some bugs, I will correct. I will work on that container which is running that login microservice. Now, once you have logged in successfully, you go to, like, what you do. Once you go inside your e-commerce site, then you look for a product catalog, don't you? Like, say,
Mm.
what are the new products added, or maybe you want to buy a pair of jeans.
Mm.
Okay, so what are the latest additions, or maybe some discounts or some promotions is happening over a particular brand of jean, and you are now. So you have to browse through the catalog. Now, a product catalog is an application
Mhm.
which does not have any connection with the login application and the login database, right? Yeah, definitely they are part of the big application, I mean that e-commerce, but they are operating loosely and they are not tightly coupled to each other. That means if login functionality goes down, that does not mean that you will not be able to. Suppose you have logged in already, but your login, suddenly the login functionality has gone down.
Mm.
So, but it will not impact you because you are already inside your site, your application, and you are already into the product catalog. So does the product catalog get impacted because of login application getting down? No.
Mm.
That's what I am saying, that each of these microservice is a self-contained application in itself, in
Mm.
its own right.
Okay. And we can say that the cart is also a
Yes, yes.
microservice. Okay.
This is one. So the cart will also, like, you have to order, or you have
Mm.
put that as a as your wish list, or your
Mm.
in the shopping list. So there
Mm.
can be one, there can be 100. So isn't it also a data?
It is.
So you have to store that shop, because today you have put that into the shopping list. After a month, when you again get inside that application, you must see that those orders are still intact. That means
Mm.
they were persisted into a database,
Mm.
a shopping cart database. So a shopping cart application is one microservice, and a shopping cart database is another microservice. So you can see there are so many containers running inside an environment. But that is also brings up some issues of security, some issues of lack of your understanding of the health of the containers, whether the containers, out of hundreds of containers, you may lose track
Mm.
whether each of the track is fine, healthy, they are good to go, they are performing well, or few of them have gone down, or few of them are not healthy, or few are having some issues. So that becomes a big headache. More and more, the operations team starts getting headache, and often calls from the customer end. Okay, that this is not working, that is not working. And to
Mm.
maintain a microservice environment, which are complicated architecture, which is in a complicated architecture, because again, remember, each microservice will have to be speaking to each other, being a separate entity.
So I got a follow-up question. Each of those micro container that you talked about, are
Yeah,
they just
yeah,
going to perform a particular function? For instance, you talked about logging. So there is a
yes.
login, for let's say Walmart is there, Amazon is also there. So could that be the same container be housing all the logins from different maybe companies, or it's going to be multiple layers of you know resources or product that's been issued out from one container, or just a specific product? I don't know if you
Good
get my
question.
question.
I got your question.
Thank you.
I will always advise, and it's a thumb rule, that one container must hold only one application, one image. of an
Oh, an
application.
image. Okay. Okay.
Yes. So if it is a login application for Amazon, you should not, it is not because see, Amazon, eBay, they are separate companies, so they will have separate e-commerce platform. So there is no question. But even if in say in the same container of Amazon e-commerce site, in the same container where you have the login application, you should not have the login database as well in the same container. Do you understand what I mean to say?
Yes.
It is a thumb rule that one container should have one application only.
Okay.
Never,
Mr. Tapashish,
ne- yeah, yes, yes.
yeah, I just want to ask. I do understand that it's a thumb rule. It's a thumb rule, but what would go wrong? Is it because if a certain microservice goes down, the other will go down as well, or is
Yes,
that another
because
security reason?
if you are holding the say the shopping cart
Hmm.
application along with the login application, so it is not a good architecture. I mean, you can do it. Technology does not prevent you in doing that. Okay, but
Mm,
think of future. In future, if suppose your shopping cart is working well, but maybe your login is working well, but your shopping cart has some bug, something,
mm,
you will have to take down that particular microservice or that container. So that means you have impacted the login. So now, suppose a person is going to just browse through as a customer, he
mm.
is not going to be able to log in, first of all. So is that a good experience or a bad experience for the customer? Customer doesn't know whether you have put in two applications in one container, what is the architecture. So
Mm.
for the customer, it is a very transparent thing,
Okay.
isn't it? So
Mm,
I will make things very simple. As it is, microservices architecture is a bit complicated. Why
mm,
complicated? Because uh, to make something easy, it is always a good saying in software industry is that to keep things simple is the hardest thing.
mm.
Okay.
Yeah, it's
If you
definitely.
put
So,
everything, if you put everything in a box, it is easier for you, for a development perspective, for a maintenance, not for a maintenance perspective, for a DevOps engineer's perspective. Everything, if you pack up in one image or one container, that is quite good because you are only having to maintain that one container.
mm, okay.
So it is easy to maintain. But think of the worst case scenario. If something goes wrong, then what? So
Mm,
thinking of future, you have segregated out your modularized your application in smallest chunk of, I mean, uh, elements or entities, such that it is easier to maintain, yeah, but very difficult to implement. Those are two things. But as a DevOps engineer and as a good DevOps engineer and good sort of knowledge, having a knowledge of the Kubernetes architecture, how you deploy it without you having to worry about much. Let Kubernetes give you the feedback whether whichever what has gone wrong out of the hundreds of thing, one particular pod or one particular container is not working fine. It is unhealthy. It
mm.
will immediately take action against it. So your life
Okay.
becomes easier.
Okay.
That's why you deploy your complicated microservice architecture over Kubernetes, such
Mm,
that your headache is gone. That is what our automation says. Our uh, life in a DevOps lifecycle says that you need day by day as you develop your DevOps pipeline or deployment. The more and more you do it correctly, your life after the deployment becomes simpler.
mm,
But if you have not taken into consideration all these design constraints in the very beginning, then you are bound to get some issues in
mm,
future. And if the issues happen on production, can you think you will not have a very happy client. Your client
mm.
Your client may have been very good along all the time. But now, once the production issues start coming up, because the client in turn is facing a backlash from the otherwise very happy users till that point. But now the user experience started getting down. Users are complaining that even 1 month back your system was so good, but certain things have gone wrong after you have deployed something new features.
Mm,
Your experience does not come good, and every now and then you are penalized because there is a lot of SLA, service level agreement, between the client and the vendor. Okay, we are from the vendor house. Always think you are not the client, you are serving the client.
okay.
Okay, did I
Now
answer
my
your question? Yeah,
yes, my follow-up question would be
sure.
when do we as a DevOps apply Kubernetes? Because let's say we have a startup as a company and we are more of a consultancy to different clients. Um, when do we apply Kubernetes? Do we apply it based on the scale of the application?
A very good question. Yes, scale is one of the important, because for a small application like a web application, which
Mm,
does not have much to do with lots of microservices, then it is no point. You are just killing it
mm,
by using a very heavy architecture. Because see, Kubernetes will be implemented over on your cloud.
mm,
Okay, you may go for cloud services which can give the Kubernetes services over the cloud. But most organizations, to save the cost, they will hire you because you can implement Kubernetes without taking the help of cloud services. But
mm,
you will only consider Kubernetes to be implemented, the orchestration of the containers. That is in simple statement, I can say in one word or 2 words, that it is container orchestration.
mm,
Okay, you are the orchestra master. Like you have seen a conductor of an
mm,
orchestra, big orchestra of 100 musicians
mm,
playing the music all with different instruments, and there is one conductor standing in the middle of the group. Okay,
mm,
think Kubernetes that one conductor, and think of the all the musicians at the microservices.
okay.
Okay,
So
and you will implement. So if the orchestra team is only for 3 4 guys, so do you think you need a conductor?
Mm,
No, no, you do not need. So you will consider the scale of your application, the security concerns of that application. Maybe there are not much of microservices, but that application is a mission critical application. So that is a real time application. So it needs a lot of security features. In that case, you may consider implementing over deploying it over. See, you have gone up to the deployment stage. When you
mm,
have done every one of this and you have come that you have successfully deployed, then you will think of uh, the infrastructure part, the Terraform, Ansible, as well as Kubernetes.
sorry, I have a little bit of confusion there. So like the Terraform, Ansible, and Kubernetes. So
Yes.
is Kubernetes an alternative to Ansible and Terraform, or they are
No,
used in
no,
conjunction? Okay, got
no. They are, you see, these are arrows. So if you are using Terraform, if you are using Ansible, they should be coming only after you have deployed. So this will be part of your final go. That means you are either deploying it to the pre-production or to the testing or to the production.
okay.
So that means you have deployed, say, hundreds of microservices as an application over to the testing server. So in that case, you have to in testing server was created by test server was created by Terraform. Test
Okay.
server was configured using Ansible, and the test server was uh, implemented using Kubernetes or
Kubernetes.
container orchestration. So
Okay.
they are separate entities. Now, can you
Entity.
see how they fit in?
Thank you.
Okay, thank you. So, what I suggest for any of our students that mm, you can jump directly to DevSecOps. We have a very nice instructor with us, Mr. Karthik. You had a session with him earlier. Okay. So he will take all the trouble of graduating you to this skill set. But if suppose somebody coming from absolutely non-IT background, okay, I will suggest to follow this path. Okay, start with learning DevOps because your ultimate aim is to become a DevOps as well as DevSecOps engineer. The combination of DevOps and a DevSecOps is a lethal combination, a vital combination. That means you can ensure that you are definitely sought after in the market. Yeah, in between comes SRE. SRE is Site Reliability Engineering. See, one of the part of DevSecOps is whether you are being able to monitor your system correctly. Can you read your unstructured data? Unstructured data is nothing but your logs. And can you present a dashboard for the management to understand what are the critical path that you are following, whether there is something which is not happening correctly as per the design, whether there is some issues in the entire operational cycle. So all these things, this is a very interesting subject. It is very much coming up. Site reliability engineering is one of the much sought after skill set after in the recent years, I can say.
Yeah,
Many,
hi. Hello.
yes, yes.
Yeah, this is just me here. What I want to know is that what are the modules like different from DevOps, for the DevSecOps? Like, what is the difference in the modules?
DevSecOps modules are what modules means what are the things that Mr.
What?
Karthik has already told you, okay, in
Yeah.
your sessions. And about
And then,
the various
okay.
tools we
Yeah.
have already discussed in our last 7 sessions. So it will be a
Mhm.
bit difficult. The all the video recordings are available.
Okay.
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 Okay. We have discussed about AWS because see, if you intend to become a DevSecOps or DevOps engineer, you must work over cloud. There is no other option. So you have to know about cloud, and to work on cloud, you must be aware of Linux, the operating system. Uh, you cannot say no. I do not need to learn Linux. Yes, you need to learn Linux because all the DevOps tools are. You will be working in an organization where they have Linux servers, and you have to implement your DevOps tools or processes over Linux on the cloud. So all these tools are there. Then there is the Git, where you have the version control system, where the developers will put the code. That is the starting point of the pipeline. So we learn about the GitLab pipeline. GitLab is becoming very, very popular in place of Jenkins. Jenkins used to be very popular, but GitLab has come up with vast features in-house, some features which can replace so many other softwares like Jira, like SonarQube. Just now you have heard about SonarQube with Mr. Karthik, right? SonarQube is the code checker. If you have any bugs from the security concern, you can set up the rules inside SonarQube where you can check for something like DevSecOps first part, which is to check the code for vulnerabilities. Anyway, that is a lot of discussions. So GitLab has replaced many of the tools So if you have in your organization have implemented GitLab, so you have also implemented Jira, you can also implement SonarQube, you can also implement like SonarQube means the functionality of SonarQube. What SonarQube used to do with the code checking, code verification, code security implementation. Okay, all these things are very important. So code repository like your GitHub, then the GitLab for your CI/CD pipelines, continuous integration. Our main buzzword is the integration, but continuous and continuous deployment and delivery. So CI/CD, and that is implemented through a pipeline, automation pipeline. The goal is to automate, and there are various tools for doing that. So you will learn AWS, you will learn Linux, you will learn Git, you will learn Terraform, you will learn uh, Ansible, you will learn Docker, you will learn GitLab. Then there will be a very good project called Capstone project, and after that you will learn Kubernetes in our main course.
Yeah. So when we are talking
If you
about
think that
GitLab,
you
yeah. So when we're talking about GitLab, for example, if I've learned Jenkins, so
yes,
will it be like very easier to replicate
exactly.
into transform? Yeah.
It is because the art technology, that is the beauty of DevOps tools. If you have learned Ansible, you know you do not need to learn Chef. Okay. If you had
Okay.
learned Docker containerization, you do not, the technology remains same. You do not need to learn Mesos or Rocket. If you had learned AWS, you do not need to learn Azure because the cloud technology remains the same. If you have learned Linux, let's say Ubuntu Linux, you do not need to learn something. If you, even if your company is having a Red Hat Linux, all the Linux commands are valid. Same. If you have learned Git, you have learned Bitbucket as well. So these are all technology. If you learn one of the technologies, you are definitely going to learn the other one within no time.
Mr. Debashish,
Yeah,
I just
yeah.
wanted to
Tell me.
ask, does the complete DevOps course include advanced DevOps and SRE?
No, because then I cannot complete that because see what I over the years what we have found that more and more things we introduce in one single course, ultimately the students run away. You know, that is the sad part. You
Mm,
cannot make what our study has seen. It is best for the students if the course is not very long. If you have a 6 months course, if you have a 3 months course, it is too much because people are in a hurry and not. It's very practical that you want to learn something very nice, but at the same time not taking too much time because you have to sit for your interviews. So we have a ambition, we have a aim to prepare our students for the job market within 1.5 months, that is within 6 to 7 weeks. So if I include SRE with the DevOps, okay, though it is mentioned fundamentals, but we cover the advanced DevOps as well within this. But SRE we cannot complete because SRE is, there are few elastic, you know, elastic stack, and that elastic stack comprises of elastic search, your elastic search, then you have the log stash, you have the bits, okay, file bits or whatever the log bits, then you have the Kibana, the Grafana. So
mm,
all these things are itself a tool. You cannot include them, otherwise the course will become a 6 months course or at least 3 and 3.5 months course.
okay, I see. So
So
what if
that is the
someone
reason we have
is,
segregated it. Yeah, yeah, tell me.
mm, and what if someone is eager to learn? Let's say they do like catch on some of the um some of the lessons quick, and like where does it go from there?
Can you come again? I mean, I didn't get your question.
Oh, I mean, if let's say someone catches quick with the lessons, they do learn quick, and yeah, and they feel like they want to learn more.
Yes, that is very good.
And what happens from there?
Yes, we have enough exercises and hands-on. So
Okay.
if we generally find students, one or two of out of the 10 students that we have in a batch, we do not exceed the batch more than 10, because generally
Mm,
we have so much of hands-on that people are bound to have some difficulties and they will come back to us again and again. So to
mm,
have an individual attention to each and every student, we cannot have a batch of 20-25. Yes, we have a lot of demand. And during the good times, now the times are bad or tough, not bad, tough. And you know, the famous saying, when the going gets tough, the tough gets going.
mm,
So we have 10 tough people, and we assure them the best of our services, because when they, after 1.5 months, when they come out, they are a very confident guy, whether
mm,
they were coming from an IT background or a non-IT background. Each of them are almost in the same level. So we ensure that even somebody knows a bit more than the other guy,
mm.
I will not pace up the sessions according to the advanced guy, because then it will be difficult for my lesser advanced guy to pick up or catch up.
Mm, mm.
So it is a very democratic set of a setup. You know, democracy is very good.
Yeah. Okay. So essentially, it's more like we have to. It's like the aim is to master the basics, and you guys are gonna set
You will
us.
have enough advanced topics
Mm,
with examples and hands-on. Maybe I will not be able to cover those advanced topics, but my
mm,
documents, my exercises, my exercises are all step by step. So you will not find any difficulty. You follow the steps, you will
mm,
end up. So if I cover 80% of those things, so 20% advance is not covered in our session. But the 80% that we cover is enough for you to learn DevOps the best way.
mm,
But that 20% which remains, if you are a good, I mean, you are advanced guy, you will use that 20%. That is your advantage.
mm,
So we have to differentiate within our batch also. We have to reward the guy who had learned better. So
mm,
that 20% is always there. So uh, we have designed our course in such a way that advanced DevOps, this is just to not scare away our non-IT guys, such
mm,
that
okay.
they know that we start from fundamentals, we start from scratch. So they are also have a chance, they have an opportunity to learn DevOps. Why not? It is for everyone. See, a person from non-IT, can they directly jump to become a Java developer? It becomes very, very difficult, because that world is too much saturated. And if you want to start fresh for as a development guy, then you have to start from the beginning, but you will face a lot of competition.
Okay.
Whereas a non-IT guy will be able to easily incorporate. Now, there is always, you have to be given some scope of development. You will go gradually as you mature, you will get interest. Say, let's say you are doing a pipeline of GitLab or
Mm,
Jenkins using shell script. Okay, because shell script is easy to implement and know, understand, because it is very simple. We will learn shell scripts in our Linux session.
mm,
But let's say after you have done 1 year of job in a good company, then and your company is using Python scripts. Yeah, you were managing with shell scripts, but your
mm,
pipeline scripts will be better if you can use Python scripts or maybe Groovy scripts.
mhm,
So there is always, because now you have been incorporated, you have been inducted to that world in that domain. So now even a non-IT guy, after 1 year of rigorous practice, rigorous this thing, he will be interested to learn Groovy, learn
Mm,
Python script. Python language and Python, like the JavaScript and Java is not the same. Similarly,
mm,
Python script and Python, they are totally different.
true.
So that is why you cannot jump. I will not suggest, as a mentor, I will never suggest a non-IT guy. Yes,
Mm,
of course, a person who has not gone through DevOps, but he's very good in IT. He has good
mm,
fundamentals of databases, data structures, uh, operations, and all this stuff. So I can suggest that instead of going to SRE after completing the DevOps with the advanced DevOps concept, directly go to DevSecOps or cybersecurity.
mm,
Don't need to go for SRE.
okay. Thank you so much.
Yeah, no problem. Thank you. So you see the top skills that is in demand in the top 5 skills, and I am not saying this is done by LinkedIn in 2023. So they found out the 5 important uh, knowledge skills. First of all, it is the Linux, 46.46%, much in demand. Then comes Docker. Then comes Bash. That means the shell script, the shell. Okay. Then comes Kubernetes. And of course, the AWS will be there. So AWS, out of all the cloud, is the most popular and most demanding. And if you see a developer or an engineer, development engineer or a software engineer has a market demand of 23%. Next comes DevOps or SRE is 21%. If you are an IT manager, you are in demand for 18%. If you are an IT operations or infrastructure guy, your demand is 9%. Okay. So these are the various statistics. Average salary for Kubernetes jobs. See, Kubernetes and DevOps. Kubernetes is so much it is complicated. It is not easy. But at the same time, I can say that Kubernetes is something which you will you can demand that I know Kubernetes, even if I don't know many of the tools of DevOps, you will get a job. That is the demand. Therefore, but what is Kubernetes? Then, if you do not know the DevOps other tools, it will be a bit, it does not fit in. So you must know other DevOps tools to be very good in Kubernetes. So the average salary for a Kubernetes job, so there can be only a job for Kubernetes uh, uh, Kubernetes, because the company has implemented Kubernetes. They need Kubernetes knowledgeable guys. Okay, maybe they do not know that much of Ansible or Terraform. That will do. But if you know Docker and Kubernetes, because Docker is the containerization technology and Kubernetes is the orchestration of the containerization. There is a total number of vacancies, but that is only a data. The essence is Kubernetes is much in demand. Kubernetes is designed by Google. So therefore, you can say that Kubernetes is going to stay in the market for long, because Google does not do anything which is not going to be used. And also not only Google, but it is maintained by CNF or CNCF, Cloud Native Foundation. Cloud Native Foundation is a very strong body. It's a body. Like WWW is a body for your internet consortium. Like there is some guidelines how you will have develop your web applications over the internet and all the stuff. How you will communicate between the devices over the internet. There is the consortium called WWW, World Wide Web. Okay. Similarly, there is a Cloud Native Foundation. So if you are doing something over the cloud, you have a framework, and that framework has been standardized by this body. And Kubernetes fits into that framework. It is an open source container orchestration system. It helps in automating application deployment, scaling, and management. That is the part which in the background will make your life simpler.
Sorry.
Otherwise, yeah.
When you say it's an open source, what does that mean? I mean, I hear that term a lot. Open source.
Open source. Open source is like it is given to the community. That means a community, a group of developers, a group of administrators, a group of IT specialists will work on this. So there is a software tool available over the market, but you do not pay for it. Why? Because you are contributing to that. You are giving a feedback. Okay, that this feature is not working, or that something is happening, that is an error, that is a bug. So you are continuously giving a feedback. And what Kubernetes is doing is continuously patching up or upgrading the software such that day by day. So it is open source. It is not proprietary. Proprietary means it is commercially released, but it is still remains there is an there are two versions. There are two versions. Okay, one is the enterprise version, and the other is the community version. Okay, so you can forgive my handwriting, but this is enterprise. So this is some licensed. So whenever you and you are commercially releasing any software over the in the market, okay, then you cannot do it over community version. That is the only restriction. Otherwise, there is no difference. This is the license. That means this will be used by whom? By the corporates with many users license. Okay, and this community can be used. Community version will be used by us who are learners, who are mentors by learners. They do not need to pay for any license fees. Or developers. Sorry. By developers, by solution architects. So many. So, even the IT managers, they can look at any software from a different point of view, but they can use it. They can implement into their own system in their desktop or laptop and can apply some application, deploy some application and find out whether some bugs are there. So many utilities are there. So basically, we are going to learn Kubernetes over the community version.
So basically, that means they produce the one for enterprise and the other one for community, which is going to be free, right? Just like Ubuntu and the other.
Yes, exactly.
Okay, cool. Thank you.
Okay, you will have Red Hat. By the way, Red Hat, the Linux, you know who is the owner of Red Hat now? It is no longer Red Hat. I mean, Red Hat is the brand of Linux. They are now taken over by IBM. Okay, so once IBM has taken over, do you think it is free? It was free, but now it is no longer free. You have to buy a license. Okay, but Ubuntu is open source. Yeah, of course, if you go over AWS or Azure, any cloud provider, okay, you will definitely get Red Hat without purchasing a license, because you have already purchased the license of AWS or Google Cloud provider or Azure. In that case, it is okay. But if you are wanting to implement Red Hat onto your system for work, you will not be able to. You have to pay a license fee for that. But it is not the case of Ubuntu. So, and when you are in the DevSecOps sessions, you will see that Mr. Karthik will be implementing Kali Linux or uh, Ubuntu Linux. But Linux is Linux after all. Though they belong to a Debian family or a Red Hat family, doesn't matter. The commands and everything will remain the same. Anyway, so is your question answered?
Yes, sir. Thank you.
Yes, that is open source. Now let us move on because that is my difficulty. I start talking too much and then I cannot complete the slides that I intended to complete within that time. So I will speed up a bit. Why you will have these slides? You can go to our site, our site, and you will find this slides as well. Okay. So I'm not going into that much details. You can read through. What can Kubernetes do? Is instrumentality, deployments, and rollout management. That is a nice fundamentals. You see, in today's world, can you think Amazon said 10 years back, Amazon used to deploy by making a downtime, and uh, there was a downtime, and then it will be some app patches will be rolled out or uh, deployed, but there will be a downtime. So what they do, they will stop what is running and they will uh, put in what is new or the upgrade and whatever, then they will again start it up. So in the meantime, as long as the downtime is happening, there will be a loss of business. You know, at say if it is down for 1 hour, can you think of how much business loss will be there? So nowadays, with the cutthroat business and the competition, huge competition, because Amazon is no longer the monopoly. Amazon, I mean the Amazon e-commerce. So there is Flipkart, there is eBay, there is so many other competitors. They have come. So if I see when I try to log into Amazon, I see the server is down or it has been taken down for some upgrades. What I will do? I am a customer. I do not need to wait for Amazon to bring up its system. I will simply go because I have to buy a shirt or a jeans or a pair of shoes. I can get that very well with Flipkart. So why should I wait for Amazon? Isn't it? So don't you think there is a loss of business? So Amazon cannot afford to do that. So they have to do something like a blue-green deployment or a, a roll I mean a rolling updates. That is one of the biggest features of Kubernetes deployment, that you can do rolling updates without seamlessly. That means nobody will know that you have already upgraded a feature without a downtime. That means you have logged in, and in the meantime, Amazon is deploying one feature, but you are not impacted. You will not be shut down from the system. You will continue your work. Nothing happens in the foreground. Everything is happening in the background, and that is called a rolling update deployment. So gradually, new things are coming inside, and the old things are taken out. When they see that the new features are working fine with the existing functionality. Resource bin packing. So you can declare what is your requirement for the resources. Like along with the deployment, Kubernetes can determine what is the CPU memory usage that will be needed for container upscaling and all those stuff. So all these things are done automatically with the help of Kubernetes services. These are very easy to hear, but very difficult to implement if you did not have the support of Kubernetes, because you are dealing with microservices, hundreds and hundreds of containers. Okay, so auto scaling and discovery, inbuilt service discovery and auto scaling. This is a very important feature. And with this Kubernetes, you can automatically see out of 100 applications, you want to go to use a particular application, access a particular application. What will you do? It will be very difficult to wade through a mesh of containers. How do you know, and how will the system know which container you or which application do you want to access? So that is called a service discovery, and that can be easily done. Unfortunately, I cannot use the cannot demo it over a internship sessions, but actually in our main course we do a lot of hands-on, and we really play around with the pods and all those stuff. So we can easily see that how easily we can discover a particular service without much of a hurdle. Yeah, you have to know the technology. Auto scaling, that means you are adding up resources to the containers automatically. So auto scaling is done. You can also, with the help of Kubernetes, go for heterogeneous clusters. You can have communication in between the clusters. Two Kubernetes clusters are there, and you want to cross configure or cross communicate within the platforms, within the two clusters. So you can do all these things. Persistent storage. If you have a knowledge of Docker containers are not persistent. So you need to implement Docker volumes, but Docker volumes are not that stable. I will not say stable, but there can be security hazards. Whereas the volumes or the storage that you implement over the Kubernetes, it is called persistent volumes, PV, and you claim the volumes. That means you consume the volumes. You use the volume is like a hard disk storage, but that clustered storage is something then what you can visualize, like your laptop is having a hard disk. It is the same concept, but think of it, you have a storage that is going to cater to shared, you know, microservices. So maybe out of the 100 containers, 20 containers are pulling up uh, or sharing the same storage. It is a bit difficult to implement on a Docker architecture, but with the help of Kubernetes, that is quite simple, because uh, you have this persistent volume PV and PVCs, persistent volume claims. So the technology of persistent volume claims will only go and hit the persistent volumes. Anyway, that is a different topic. We have to learn about that. But what I'm trying to say is storage in Kubernetes is a very stable and a very widely used service. Okay, because always remember the containers are ephemeral. Can anybody tell me what is ephemeral? Containers are, I say, ephemeral. Ephemeral and persistent. These two are antonyms. You know antonyms? Opposite words.
It works, yeah.
Ephemeral, opposite. Yeah,
Yes.
opposite word. So ephemeral is temporary,
Short term.
and this is permanent. Okay. So I will always like to go for something which is persistent, because our containers our containers are very, very ephemeral. If the container gets down, so what is inside the container? As you have learned from Docker, there is an image or an application. There is an image or an application, or you can say uh, a microservice. A microservice. A microservice is there. So there is some application. It is running inside the container. So yeah, this image cannot run itself. You can run a container. So if you run a container, that means you are running the image. But suppose the container being a very ephemeral in nature, suddenly gets down. It vanishes. It somehow vanishes. No reason. So that is a problem. So you have to somehow make it persistent. Or the data coming out of this application or the data consumed by another microservice. This is another microservice. They are linked. They can talk to each other, though they are loosely coupled. Loosely coupled. Okay. They are loosely coupled. They are no, there is no dependency between these two microservices or the containers, but still they have to talk to each other. Let's say this is the login application and this is the login database, a microservice. Okay. So they need to, when I log in, I have authentication. I have given my login credentials along with the password, but then that has to be validated. It has to consult this. So this container has to talk to this container to validate the data from the database. And then it will respond whether the user is authenticated or not. Okay. So there has to be some communication. But suddenly, if your container gets down, so the data has to be persistent. That's why the persistence is very important term in terms of microservices or containers. And high convenience options. We have another 45 minutes. Okay. So let's see. Don't worry if we cannot complete today. We will again shift because there is already one more session scheduled. That is the next weekend, Saturday. So don't worry. We will see how much we can do. Why industry has adopted Kubernetes is because of these 7 use cases. All these use cases are very important for our industry. And therefore, Kubernetes can cater to each and every one of these use cases. That's why this is the symbol of Kubernetes. It is like a ship, steering of a ship. And you know, Docker is like a container on a ship. So the symbol of Docker is like a whale. There is a very famous story about that, why they have adopted that logo for Docker, a whale carrying the containers. Okay, that is a Moby project. Moby Dick. Moby Dick was a famous whale in some novels. There was a famous movie called Moby Dick, and the hero was Gregory Peck. It's a famous Hollywood movie. But anyway, so that is because Kubernetes steers all the containers, and those are Docker containers. So it is like a steering wheel of a ship. That symbolizes the orchestration of the containers. Simple app. It can cater to microservice. You can deploy microservice. See, orchestrating complicated apps. Microservices are not simple. They have to follow 12 rules. Okay. So then you say that I have built up a microservice. You will not say, because it is the part of developers. Developers will develop the microservices, but you have to deploy it. So if you know about a bit of microservice, that will help. But Kubernetes is a master of managing the microservice. So that is one. Lift and shift. it is one of the best utilities for a tool for operations guys. Operations guys have to often do a lot of movement between on-premise and the cloud. So many applications do move, not only applications, infrastructure, and so many things, network, applications, servers, they will always keep on moving from on-premise to the cloud, because many organizations are coming out from their legacy systems and going into the cloud. Okay, because they find it very difficult, hard to manage and maintain along with the capex and opex. So for a cost cutting or easy maintenance and giving up on the system is very difficult to maintain. But the way of migration is very helpful with Kubernetes. It is just enabled on the philosophy of lift and shift. You lift a thing and put it, like you are transferring some data from here to there. That's all. You lift it up and put it there. Lift and shift technology. It's a very famous technology. And because it is within the framework of cloud native functions, CNF, it enables machine learning. So you can deploy AI based apps faster on Kubernetes. So Kubernetes is not AI agnostic. Uh, there might be a myth that with AI coming to the market, Kubernetes will die. No, in fact, they work together very well. So AI-based apps can be easily and seamlessly deployed onto a Kubernetes orchestration architecture. It will enable heavy computing, heavy task, AI task can involve a lot of complicated analytics. Okay, over the Kubernetes that is possible. So you can have tools which can seamlessly work over Kubernetes. And of course, the main feature is the CI/CD. So you have a GitLab CI/CD pipeline which you can easily deploy onto Kubernetes. So you like a lift and shift. You pick it up and put it on the Kubernetes. So all your applications deployed over the CI/CD or the jobs will be very safe, will be easily monitored, will be easily governed, maintained. You have given the headache to the Kubernetes and you have a good life. Why that is what we were discussing, isn't it? That we are coming out, our world is moving towards from the monolithic application, a single layer application, into the microservices application. And to deploy a microservice, so these are highly or tightly coupled and not independent. So you have an application having a front end, back end, and database. So in the front end, you have the the front end applications like Angular, React.js, or whatever, Java, that in the front end, and that have a back end. So some middleware will be there, or some business logic will be implemented on the middle layer or on the back end. All the business logic of the organization will be there. And then so front end will interact with the back end will interact with the database. Front end usually does not directly connect with this is called three-tier layer. If you did not have the backend, you will say it's a two-tier layer, front end and the database. But that is a weak architecture, not a good architecture. You must have a backend. So you have to filter the request from the front end and enable it onto because database is the main thing. Information is all about data. There is nothing else than what you are doing. Finally, you are implementing Kubernetes, you are implementing Docker, you are whatever you are doing. But ultimate aim is to get an information out of, you are trying to represent a data. You are trying to present the data. You are trying to analyze the data. So database is very important. But anyway, my question is not that. My question is why we are shifting over we're gradually moving towards microservice because of the advantages that we have already discussed. These are uh, loosely coupled. So yeah, still there is front end, still there is back end, still there is database, but they are in form of microservices, small microservices, and they are many the capacity of the user request. So yesterday you can process only 10,000 users per second, but today it's a Christmas day and there will be 1 million users hitting your application. If you are doing a monolithic, the performance will degrade. More and more requests coming in and hitting your application, the performance gets down. Whereas this is the advantage of microservices. It can cater to 10,000 per second, or it can cater to 1 million requests per second, because there is an auto scaling. Understood? The beauty is auto scaling and replication. So many things are there. Very interesting subject. Storage persistence. So the persistence, so your data is safe because you can persist your data over anywhere over the cloud using simple services of Kubernetes. And also there can be in future, there can be many microservices waiting in the queue to be deployed. Doesn't matter. Enough. This Kubernetes has a huge capacity to cater to service all these microservices. Hence, there is a need to maintain and monitor and govern the containers for their health. This is most important thing. You have to find out immediately, without any delay, whichever microservice has gone down or not healthy, not responding, or this is almost like capacity is almost full. So you have to auto scale it. You have to increase the sorry. All these things, you have to make them available. You cannot afford that a microservice the container gets down, so I am at loss. No, you must immediately replace that container with another container. So that is called pod replication. That will make your availability almost 100%. There is no downtime, as to say. You are making your application more stable. That there is a need for container orchestration. Now, did you understand why you are learning Kubernetes, or why you should be learning Kubernetes? Any questions thus far? For almost like half an hour, I was not getting question.
We wanted to finish.
No, that's not the aim. Objective is
Okay.
the session should be interactive. I should not be just browsing mechanically through the slides without having to understand that you have at least learned uh,
Yeah.
the concept.
So you talked about auto scaling the other time. So in AWS too, there's also auto scaling there. So I mean,
Yes,
is it the
yes.
same thing or kind of different or?
Yeah, kind of same thing, but you are paying a price over AWS because you have to buy that service.
Okay.
It will be built. It will be built if you are using that service.
That service.
Whereas when
Okay.
you do it over Kubernetes, enterprise, you have paid a license. You do not need to, for every usage or for every auto scaling that is happening within the cluster, within the Kubernetes cluster, you do not, for each hour, you do not have to be built. That is the
Yeah,
big
all
advantage.
inclusive.
All
Yeah.
inclusive, everything inclusive. So why will
Okay.
you like to get for AWS service with a price? Kubernetes has that feature. Use it.
Okay.
Therefore, I said that you see there is a resource bin packing. This feature will help you to auto scale with more CPUs, more memory, more space, more storage. That is what you need for auto scaling. Whether the auto scaling will be horizontal or vertical doesn't matter. You do not need to get worried about it. You leave it on Kubernetes. It is a master.
Oh,
It will do.
so everything
Yes.
is built into Kubernetes
Yeah, these are the features which will be
features.
provided.
Okay.
But of
Okay.
course, you have to configure it a bit.
Oh, okay.
So that is the beauty, when you learn something, you learn the necessity, the role. Uh, you feel the need. Okay, then you say, okay, I have to do this. So auto scaling is the need. So I will declare something within Kubernetes which will help Kubernetes to auto scale. See, everything cannot be automatic. Kubernetes is not that intelligent that it will understand what I want. I have to declare through declarative scripts, through manifest files, what I want. My question more important is what than how. How Kubernetes will take care. What I need to design, I need to feed in. Are you getting me? So my architect says that I want in the times of peak time, it will be two more CPUs will be added to your pod or to your architecture or to your application. Okay. So that is what you have to configure. You have to tell to Kubernetes that, see, when I deploy these pods, so through a deployment manifest, I will mention the resources that will be required in times of auto scaling. See, when the need be, we will come to that architecture. Who will decide whether that pod needs to be auto scale or not? Somebody has to decide. But those are decided by the Kubernetes components that we are going to learn. Okay. So that is the need for a container orchestration, because you have several microservices and you need to monitor the health. You need to talk. There may be a need for, though they are loosely coupled, they need to be talking to each other multiple ways. So how do we have a network architecture enabled between them? All these things are the question of the Kubernetes. So what features do orchestration tool provides? Offer high availability or no downtime. That is very, very important. Every customer is wanting, there will be an SLA between the customer, and the customer means the client, and the vendor. Let's say IBM is the vendor, and the client is, say, whatever client, say AT&T. AT&T is a big telecom giant. Okay, they have employed IBM as a vendor to implement Kubernetes. And they have mentioned in the SLA that I need 99.95% of availability of the application deployed. So basically, they are saying that if there is a tolerance level of 0.5%. So up to 0.5%, I can tolerate that there is a downtime. But if it is 1%, that is, instead of 99.5, if it is 99% available, then there is a penalty, because the availability requirement for the client was 99.5. So how will you ensure that you do not put the money from your pocket? The vendors has not to bear that expense, I mean that penalty. Is I will ensure that I will involve the best of technologies like Kubernetes, where I can ensure high availability, high scalability, or basically high performance. So my performance will never come down. If I need some scaling up, I will do it automatically, because I have already declared to Kubernetes that if need, you will scale it up by 2 CPUs, or by 10 GB, or by whenever there is a threshold of 80%. Let's say there is a it has gone up to 80% of usage. So immediately you scale it up. So all these things, metrics will be defined. Disaster recovery, backup and restore. Fantastic. There is a replication.
Mr. Debashish,
Yes. Yeah. Yeah.
since you mentioned that auto scaling is utilized when there's an influx of users, right? and
Yes.
it allocates how many, if you can correct me if I'm wrong, it allocates how many CPUs can be used.
Yeah.
Then where does load balancing come in?
Oh, fantastic. So uh, we are coming to that. Can we park that question? I want to explain that question in bit details.
Okay, no problem.
Until and we understand the architecture, the cluster, it will be a bit difficult for me. Yeah, you are absolutely correct. But load balancing and auto scaling are two different things, two different features.
Mm.
Okay. Load balancing is you are having an external load of requests coming in from some external sources. Okay. And
Okay.
gradually there is a surge of request. And load balancing will, what will it do? It is front ending the servers or where the applications are running. It is in front of those servers. Okay. So the request cannot directly go and hit the services. The request has to go through the load balancing, because a load balancer will have a technology of round robin logic. I mean, there is a implementation of that logic through which it can find out which node is a bit less loaded
Mm.
on the node specific. Here we are not talking about load balancing, is not talking about, it is not going to individual pod level to understand whether this pod or this container is heavily loaded or
Mm.
not. It is
Okay.
not playing. It is not playing on the application level. It is playing on the infrastructure level. That means it will go and find out on a node, say worker node one, whether
Mm.
how much is it. Is it there is a threshold of 80%. So if it is 80% fully occupied, so I will shift over to the other node available in the cluster.
Mm.
And if that node is, let's say 60%, okay, I will send that request, distribute that request over to that node to access that particular application. But the auto scaling happens not on the node level, it is on the pod level. For that, that is what I said that I will need to park that question right now.
Okay.
And we will go to understand the architecture. I have around 20 minutes, 20 or 15 minutes. So let me just give you a preliminary view of the Kubernetes cluster. But we need to study this cluster, because unless and until we understand this properly, our learning is not proper.
Mm.
In our main course, I go into much details and with lots of hands-on, so the students get it very, very clear. And when I speak, maybe or may not be, it is 100% clear. But unless and until we do some exercises, some hands-on, some examples, some demos, practically seeing that how things work. Till that point, it will be a bit, but anyway, I will try my best. So let's say this is a Kubernetes cluster. We will implement our cluster in our main course. How to install a Kubernetes or implement a Kubernetes cluster. There is a lot many steps. It is not simple, but yes, if you know, learn it properly, it is not difficult. But the one thing is, if you learn difficult things, your life becomes simpler. Your life becomes easier later on. If you learn simple things, you can easily get some things very simply, but to achieve greater things in life, it will be difficult. So always aim for learning something which is complicated. That's why we have kept Kubernetes at the very end of I even have kept it after the capstone project. So with the capstone project, our students have learned all the DevOps tools and how they integrate, how they talk to each other over an automated pipeline that is building up a project. A capstone project is a real-time project. Okay. After that, when we learn Kubernetes, then the things become quite simpler to understand. Anyway, for our internship sake, I will just go through. Remember, there is a master slave architecture. Okay, there is a master slave architecture. What is master? This is a control plane. It is called a master node. So think that in this cluster, there is one server called master, and there are two servers called worker nodes in the same cluster. So this is the control plane. So you have to install that master, and also you have to install the worker nodes. There are few Kubernetes components that needs to be installed on the worker nodes, and there are few Kubernetes components that needs to be installed on the master node. So to differentiate between the master node and the worker nodes. So you can say your jobs or your application or your containers will run on the worker nodes. Okay. Your applications will run on the worker node. No applications will run over on the master node. But all things will be, all your containers, all your microservices, all your pods will be controlled from the master node. Any question? So let's say there is a simple cluster of one master and two nodes. You can have one master and 100 nodes, or you can have 10 masters and 1,000 nodes, if that is a big cluster. But if you learn an architecture of one master and two nodes, that is more than enough. That is, if you can see, if you know to do something simple, then you can also do something bigger. But if you cannot do something which is in a simplest form, you will not never be able to reach the more wider form. That is a very simple, philosophy. So we can do one master and two slaves. Now the question is, what are these? So the master have these components. One is HCD. HCD is a key value store, but the main component is API server. This is a Kubernetes component, API server. There is a scheduler, and there is a controller manager. And if you are interacting with a cloud provider or like the Amazon or the AWS with some services, then you will have another component called Cloud Controller Manager. But when you install Kubernetes for master node, you have all these components already installed. Now the question is next, what are these? These are also containers. And this is the application running inside the container. So can I say that this is one Docker container or a pod having an application called API server? That is the master. In the master node, in the master server, you have this is the brain. This is the brain. And this is the heart. So all what is happening all over the cluster is an information that will be stored in the key value store called HCD. That's why there is a symbol of database. It is a database. And there is a replica, and it is showing that ideally I should not have only one pod of a database called HCD. There should be at least two, because one pod goes down, the entire master will get down. Followed? But I can manage with one API server because API server does not hold any data. So API server, any interaction coming from outside has to hit the API server. So it is the brain. This will say, this will extract the data or latest information from the HCD and then do the necessary activities. It will ask the scheduler or the controller manager to take over. So this is the brain. So everything will interact. What is kubectl? Kubectl. Either somebody says kubectl or I will say kubectl. Kubectl is the CLI for Kubernetes. CLI means command line interface. So you as a DevOps engineer or a developer or Kubernetes developer or Kubernetes administrator or Kubernetes engineer, whatever you can say, you are issuing some commands, and those commands will be CLI, API, or dashboard, whatever, from wherever you are issuing those commands. Basically, we will do it in our learning, we will do it simple commands, kubectl commands. Those commands will come over, hit the API server. API server is the interpreter. It will understand what needs to be done as per the instruction. Okay, I will now shift my focus over to the worker node. Let's say this is the data plane, the worker nodes. This is what? The control plane. This is the master node. Let's say worker node 1 and worker node 2. What is that worker node? This is nothing but you can visualize this as a virtual server where you will have the applications replicated over into the pods. So let's say this is my Java application inside a container. And then is an abstraction layer called pod over the container. We will come to pod, understanding the pod. Okay, the next session. So these are container runtime. So I must have installed Docker runtime engine, the container runtime engine. Otherwise, I will not be able to have container. Without the container, I will not be able to hold my application. Okay. Now there is, when we install over the worker nodes, we will install kubelet and kubeproxy. So these are components over the worker nodes, components of Kubernetes. Kubelet will interact with the pod to understand what is the health of the pods. Pods are nothing but, for the time being, you just understand these are containers. And what is a container? The container will hold your application, will contain your application or microservices, whatever you say. So kubelet is one manager, container manager, or say it will just monitor, keep on monitoring and communicate the state of the health. Sorry. It will monitor the state of the health of the containers. It will communicate the health to the kubeproxy. Kubeproxy is a network element of the worker node. Why network element? Or you can say network interface. So it will take that information from the kubelet and communicate over the network to the API server. And API server will ask HCD to hold that information into the database. Now, think of a situation where, let's say, out of the 3 pods or these 3 applications or the 3 containers, this container has gone down. Are you following me?
Yes, we are. Yes, we are.
Okay. Just Okay. So, mm, so let's say this container has gone down. Who will get the information first time? Kubelet will get that information that this container is down. This information will go down to kubelet because that is a mechanism. It knows. So what will the kubelet do? Kubelet will pass this information over to the kube proxy. Okay? Because kube proxy has an expertise to communicate over the pod network. There is a pod network. Pod means the container network. There is the pod network across the cluster. This is the Kubernetes cluster, right? You have implemented where there is one master and two nodes. So, but they are a part of the cluster. So there is a pod network running in between the master and the nodes. So there is a horizontal network or whatever. So this worker node will also communicate with the pod network. So let me extend this over here. So the same thing, the pod network. So all these three nodes are connected over the pod network. So kube proxy will, with the help of the pod network, will communicate this message to whom? Can anybody tell me to whom? See, these guys cannot do anything, cannot take any action to rectify the situation. This is an alarming situation because this pod has gone down. So how many pods are there remaining? Two. This pod may also go down. So you are in a very risky situation if you do not take any action because this can go down any moment because pods are ephemeral. Okay. So you have to immediately, proactively take a stance, proactively work with your, you have to do something about that. So immediately kubelet will give that information to kube proxy over this pod network will communicate where?
So AP server.
API server. Yes, because API server is the brain for the master. So API server will give that information to be stored in in both of them. If there are two pods of HCD, both of them. So the same information that one pod is down, this pod will have a label. A label will be there. So each and every pod will be labeled. So this information will be stored over here. Okay. So the next step is API server will talk to whom? API server will immediately talk to the scheduler, saying that Mr. Scheduler, please look into this because I have an information from kube proxy of the node that there is a pod which is in trouble. Okay, the health of that pod is not good. I can see that it can go down anytime, or maybe it has already been down. So please take an action. What will scheduler do? Scheduler is something like the very name suggests, will interact with the controller manager. And the controller manager will validate the action that is that will be done by the scheduler. It will, so controller manager is something in between all these elements so it's an interface between the worker nodes and the master node. Though my diagram says that it is over here, but actually it is over the entire. So it is an interface between the master and the worker nodes. So what will happen? This information will go, the scheduler with its activity will go to where?
Controller manager.
The controller manager, yeah, from the controller manager. Now it will go to whom?
all the way to the worker node. Where?
Yes, worker node. Yes, it knows, the scheduler knows which worker node. So it will go to the worker node 1 because worker node 1, this pod is down. So it will interact with kube proxy because that is the network element. So scheduler through the controller manager has contacted kube proxy. Kube proxy immediately will contact kubelet because the kubelet is the manager for all these pods. I cannot directly kube proxy does not have the role to interact with the pods. Okay, so kube proxy will hand over the action of scheduler over to the kubelet. Kubelet will interact with the pod. So what will it do? Scheduler in fact has made an arrangement that it is called the replication manager to immediately replace this with another pod. So another pod is created. Pod is created. So see, the pod was down. The pod is made up immediately. And my drawing takes a bit of time, but this does not take even nanoseconds. So fast. But is this the working, how communication happens between all these things more or less clear?
So the new port now that is now created, will it be created from the Kubernetes or
Yeah,
where will it be
everything is
created
being
from?
done by Kubernetes. But you are saying that whether it will be the same pod? Yes.
No,
The
what I'm saying
application.
is where is it going to be created? Is it going to be created from one of those two other ports, or is it going to be from the Kubernetes? You know.
Yeah. It will be, the kubelet will ultimately help scheduler to uh, there is a there you can see these are the Kubernetes objects. These objects, so there is a deployment manifest file, YAML file, YAML file. Okay, these are things we are going to learn. But this is like our instruction. I have given an instruction. What happens if a pod is down? I need a
Mhm.
replica of 3 replica sets. That means I need the same pod to be replicated to have a replica of 3. So when the 3 becomes 2, that means 1 is down. So immediately my deployment through the API server will know, or the API server will consult the deployment manifest and say that no, they always wanted 3 of the pods of the same application to be running at any point of time, but 1 is down. So I will have to again get it back to 3. So what it did, it replaced the faulty or the unhealthy pod. It will take it down and it will create another pod with the same
So
application. It is
that
replica. What is
okay.
replica? Replica is nothing but a clone. Replica is nothing but a clone. Because you cannot, this is a Java application. Okay, this is a Java application, same application running in 3 containers as a replica, as a clone. So 1 gone down, the 2 can handle, but 2 gone down, 1 can handle, but all gone down, it's not a good design. So you must use a replica. And what I desired that any point of time there should be 3 replicas running for the same application or the same microservice. Anytime any one going down, you have to bring it to 3 through this flow, through this data flow. Is it clear? So today I will stop over here, though I know there will be lots of questions, but my boss, Mr. Menon, should be very unhappy with me if I exceed my time. So I will stop the discussion over here, because I know I will have the next weekend to again continue with this a very interesting discussion. We have covered only 12 out of 29 slides. We will do that. So this is what we have for today. Okay. Mr. Menon, I think we can end the session today. Thank you.